Good afternoon, everyone. So we are Group G, and our topic today is supply value. So first of all, let me go through the agenda. We will talk about why we have to use supply value and what is it. Then we discuss the fairness axioms of supply value, and then Omar will help me to give some applications, especially in machine learning, and then the pros and cons of this methodology. Right, so let's start with why we have supply value. So, like in the reality, when people or features work together to create like a common result, we will face the problem, the fairness problem. Um, the first one is who contributed most among the contributors. Um, like sometimes the contributions overlap. Your contributions only matter when you combine with others. Just imagine that you are the presenter, and without a content builder, you have no content to present, so you cannot generate any value. So in that case, we cannot base on the individual performance to like to define the contributions of the player, of the member in the group. The second one is how to divide the credit or profit at the end. So if you are like you work in a group and in a business project and you got a profit, then how to divide it? We cannot divide equally because we will ignore the difference between the contribution. And we also cannot base on the individual performance because we will ignore the effect of the synergy between them. Okay, and the third problem is what is a fair share? Fairness is difficult to define because your contribution impact depends on the order that in which you join the team, and also who is the one working with you. In different situations, you generate a different value. So to solve that problem, Shapley value was created. Shapley value is like a method, a fair answer to the questions who truly contribute what. So let me explain what is that. So an official definition for this concept is it's a method to fairly distribute the credit or value among the contributor based on their individual contributions. And this is the formula of it. So to make it more simple, I will write something on the board with an example. Okay, so let's imagine there is a group assignment, just assignment, and it can be done in group or individually. So, and there are 3 students. We have Alice as A, Ben as B, and then Chris as C. Okay, so 3 of them worked together on the assignment, and they got 90 score over 100. So if A work with B, work with C, they have 90 score. Right. So the question here is, how much of this 90 score should I credit to Alice, to Ben, and to Chris fairly? So to answer that question, we have to compute the Shapley value. And first of all, I will have some other fact is that if Alice work alone, she will get 60 score. If help us. Alright. If Ben work alone, he will get 50. If Chris work alone, get 40. Then if Alice work with Ben, they will get 80. Then Alice work with Chris, they will get 70. And then Ben work with Chris, they will get 55. Right? So this is the initial value that we have. Then I want to mention again the function, the formula of Shapley value. Okay, Shapley value equal to the average marginal contribution over on order. Okay, so what is on order here mean? So because we have three students, so they will join in the team in different order. So I will write the possible orders of their combination here. So we will have Alice join the team first, and then Ben, and then Chris. Or we have Alice, then Chris, then Ben, and keep going with it. Alright, so we have 6 different order of the combination. Okay, so next one, we have to calculate the average marginal contribution. So what is the marginal contribution here? It means the extra value. Okay, it means the extra value that player, that student contribute to the team. Okay, so and then let's say we're trying to calculate the Shapley value of Alice first. So Alice have 3 different positions in in order. For the first scenario, if Alice joined the team first, I would say Alice first. Alright, so the first thing I will calculate is the marginal contribution of Alice when she is the first one. So I write the contributions of Alice minus C0. So the correlations of no one, I would say it's 0. So it's equal to 60 minus 0 equal 60. Okay. So another thing I want to compute is the probability of this scenario happen. So I have P of CA minus C0 is, you can see it, there's 2 scenarios, Alice is the first one among the 6 scenarios. So we will have 2 over 6 equal to 1/3. Okay, so the second scenario is Ben first, then Alice. Okay, for this scenario, I would write it like the value of Alice and Ben minus the value of Ben only. Okay, so we have 80 minus Ben only is 50, right? So I have 30. And the probability here, what is the probability? Can you say? The probability that Ben first and then Alice. Okay, so so there's only one scenario that Ben first then Alice here. Ben is the first one of the team and then Alice join, right? So it should be 1 over 6. All right. The third scenario is Chris first and then Alice. So it's the same like CAC minus C. Alice and Chris is 70, and then Chris only is 40, so it's 30. And the probability here is also 1 over 6. And the last scenario is Alice is the final one join the team. So I would say Alice last. Okay, so we have CABC minus CBC because Alice is the final one. So I will take the score they work together minus the score of Ben and Chris only. So it's would be 90 minus 55, and it's 35. And the probability here is also CABC. CBC. We have like two different case that Alice is the last one. So it's two possibilities. So it's 2 over 6 and it's equal to 1/3. Okay, so now we have like enough value from like every orders of Alice. So I will compute the Shapley value of Alice equal to 60 multiply the probability of that scenario is 1/3, then plus 30 multiply 1 over 6, then plus 30 multiply 1 over 6, then plus 35 multiply 1/3. And this equal to 41.67. Okay, and this is the Shapley value. So you can see we calculate the marginal contributions of Alice in every order. Then we take the average of it by multiply the weight. So if you like keep going with Ben and Chris, you will got the answer is Ben is 29.17 and Chris is 19.17. And if you like sum three of them, okay, you will have 90. This is the like the total score of them together. Alright, so with this result, we can have the like the foundation or the like the clue to like divide the credit to three of them. Okay. So back to the formula, I would like trying to circle the component to make it easier. So this component is the weight, is the probability, and inside this bracket we have the correlation value after that player joined the correlation or joined the group, and the second value, the VS, is the value of the group before the player joined the group. So we have the marginal contribution for this component, and then we sum it up. Right. So that's how we compute Shapley value. And next one, I would like say something about the axiom of fairness. How we define the fairness in case of Shapley value. So it satisfies the efficiency. Efficiency here means the sum of on players Shapley value equal to the total point of them work together. As you can see, it's 90. When you like sum Shapley value of Alice, Ben, and Chris, it's equal 90. Right, and the second one is symmetry, which means if players who contribute equally, they will receive the same Shapley value. The third one is null player, which means player who contribute nothing will receive 0 Shapley value. And the last one is additivity, which means like if you have two assignments to form a set of assignments, and you calculate the Shapley value of Alice for a set of assignments, and that Shapley value equal to her Shapley value in each assignment sum together. So these are 4 axioms of fairness that Shapley value satisfy. Right, and next one, Omar will continue with the applications.
Hello. Let me walk through the application of the Shapley value in the real world. Let's start with the easy one, more complex one, teamwork and business. Shapley value allow us to answer a simple question: who contributed what? So they can fairly divide the profits among the team players, and also indicate us the contribution of each player in the collaboration project. This is very useful when like you have a collaboration project and you don't know, for example, for the teacher who doesn't know who contributed the most. The second application is supply chain operation. Like when you are working in the supply chain management and you want to allocate the cost of the supply chain, like for example warehousing and transportation, the Shapley value allocated to efficiently allocate this logistic cost to the components of the supply chain. Finally, the machine learning and data science, which is we found the most interesting. It allows us to do few things, like it help us to understand like black box, and but most important, in our opinion, is that they help us to, if you have a very large data set with a lot of variables and you want to do some feature selection, shepherd values is very useful tool to use. So now about that, I would like to introduce you this very brief example. Like step one, where first of all we run the first baseline model, which all the feature, all the variable, we collect the prediction, and then we start to refine the model. How we're going to do? Step two, we calculate the shepherd values. So for every single prediction, we break down how each observation is, each prediction has been predicted by the variables. So we create the matrix that you can see, where the columns are the observation and the rows are the observation and the columns are the variable, and inside of the cell there is the shepherd value. As you can see, they have like a positive or negative. Step 3, we compute the mean absolute shepherd value. Since you can see for each feature we have a lot of shepherd value, we need to calculate the mean absolute shepherd value. Why the mean absolute? Because we are not interested about the direction, but about the magnitude each feature delivers. After that, we will be able to rank them, the variables, and to select it. So now, to select it, of course, we can use two options. The first option, we can use the top K. So, for example, we have 20 variables, and we decide to select only the top 5. So we're going to select from the ranking only the top 5. Or we can use option B, which is threshold. Like we set up a threshold. Okay, let's the machine say, give me back only the variable which have a shepherd value over 5, and is going to select only that variable that respects that result. Then finally we have all final model, refine it. So we run it again, and the expectation is that the model is going to perform better, so with improved prediction, which is going to be more accurate. So let's look at the pros and cons of the shepherd value. So as you can see, one of the most important is that, as explained, it allows us to do a fair and principled allocation of value, but requires to do so, it requires a clearly defined value function. Another advantage is consider all possible order and contribution, but if we have a large number of players, it can be computationally expensive. Another advantage is this is very transparent and understandable, but if the context is ignored, it can be very misunderstood. Another advantage is can be used in every various domains, but when we have a large model, we need an approximation with can lead a less accuracy. So now to conclude, to wrap up, I would like you to raise up your hands. I'm going to read some statement, and I would like you to raise your hands if you say, okay, this statement is true, or you keep your hands down if you think the statement is false. Shepherd value is a method to fairly distribute credit among contributors. Okay, correct. Shepherd value calculates the average contribution of each person across all possible information. Okay. So, but the one that keep it down is because they don't understand, or because efficiency means that the total value is completely distributed among all players. It's true. Symmetry gives more credit to the player who joins first, even if contributions are equal. False. New players are still rewarded even if they contribute nothing. Good. The order does not sorry. Additivity means the Shapley value for combined task equal the sum of the values for each task individually. Good. The order in which team members join a task does not affect their marginal contribution. Correct. Thank you.
Okay, let me just ask you to add one aspect. So in the stuff that we have on the board with Alice, Ben, and Chris, so these are three persons in very many everyday situations. Their total contribution would be split evenly, one third, right? What's the problem with that?
So the problem is that like we ignore the difference between the contribution of them to the team. So we can say Alice worked harder than Ben or harder than Chris. So it's unfair to credit equally.
And also, if you can see, if I know that he can alone can generate more, like he can have a B score. If you divide it by 90, he's going to just to have 30. So he will not be willing to collaborate with the other players.
Yeah, so that's the fundamental thing. The breakdown of the coalition, it is in the interest to coordinate many times, and we saw that in relation to the previous presentation. But if the contributions are unfairly, in the sense that you have defined it here, unfairly distributed, which it would be if they all got to the same credit in this case, why would Alice stay in this coalition?
Because like if Alice synergize with the other, she would have like an increased score.
Yeah, but the problem is if she was awarded just 30 scores because you apply this common way of doing it, she gives 1/3.
If you use supply, you will get 41.
Yeah.
Much higher.
Yeah. So by also applying the shape value, we increase the likelihood of a sound coalition to survive. A very hands-on. I don't know if any one of you are following cycling, but the greatest biker now is Tadej Pogacar. He races for the team UAE, United Arab Emirates, and when they do the big tours, they would either be 6, 8, 10 in the team. Tadej Pogacar would never win if he was not supported by his team. But the prize money goes to the winner. So on the one hand, he, in order to win, depends on the team members. But in the end, he, because he always wins, is the one who wins the prize money. So how should he behave in order to ensure that his team members are putting their maximum effort in assisting him in winning stages?
Well, I will say that he will like willing to share his winning with the team members.
Yeah, and he would have to do it in a way which resembles the Shapley value.
Exactly.
Yeah, because otherwise he would never win.
Because
and if he was sort of distributing it in a way that was not well representing the module contribution of the different team members. They will not, you wouldn't see these guys that for 3 hours are staying ahead at the very extreme of their efforts, most likely for hours, thinking I would just want to lie down and die because this is so painful. They sacrifice themselves completely for him, and they would never do that if they would not be seeing the situation as just.
Also, he should use this because to avoid free rider. Like if instead he share the income independently, like someone can say, okay, this guy didn't do nothing, so why I should do nothing? Why should I do something? Instead, if you use this, it's okay, everyone has to bring his own contribution. So that's why it's kind of more efficient in this way.
Yeah. Okay, thank you. We'll take a little break and we pick up 10 past and let's see. Yes, the victory auction and team A, you can make yourself ready in the meantime.